Hello guys, welcome back to the class. I welcome you guys to today mathematics class, and in this particular video, in this particular class, we are going to dive into this topic mathematics called indices. Now you are familiar with it, and some of you say it's difficult on this particular topic called indices. This topic you can do without no kind of exam you want to write in this Nigeria, that you can't escape any question on this topic. So it's very important. So that is why I was unable to come up the easiest way to master these indices in a minute. This class is meant for SS1 to SS3, WAEC candidates, NECO, JAMB, POST-UTME, NABTEB, GCE, any kind of exam you're writing in Nigeria. This class is meant for you guys. So I think by now you should have your pen and your lesson note with you. Guys, let's dive into it. So guys, if you are just joining my channel for the first time and watching my video for the first time, do it to subscribe, like, also important in case you have benefit like this, you'll be the first one notified. Please share this video, this particular video or this particular channel, share with them, so they will have the opportunity. So they will have the opportunity for this class. So this class is very, very important. I do give free lesson for us Nigerian students here. So without wasting our time, let's dive into the main problem we want to solve today. Yes, the problem is what we want to solve the easiest way you can master these indices. So after this video, I can guarantee you that if you see any question that indices, you will be able to know how to solve it. Okay, so let's dive into it. Okay, the easiest way to master indices in minutes. So what do you understand by indices? Okay, indices, they are number with power. They are the power, and it can express as whenever you see a question in mathematics, we give an expression as we have a raised power of n. So this index always has two parts. Okay, it has the base and has the index itself. Okay, this n, it means that the how many times that this a are multiplied by itself. It means that the number of times that this a multiplied by itself. Okay, so when you give an expression like this, if you have an example, for example, now if you have a 2 raised power of 3 or 2 raised power of 3, it means that this 2 is the base, while this 3 is the index. Okay, this is index form, and this this indices is the plural to this index, right? So in this place now we have this 2 multiply itself in 3 times. So if you want to express it in normal mathematics, we have 2 multiplied by 2 multiplied by 2, that is in 3 times. So that is the meaning of words. If you are, for example, now maybe you want to write 2 multiply itself in 100 times, and so we write 2 times 2 times 2 in 100 times. So you just call the word law of indices to it. Just put it in index form. That will be 2 raised power of 4. Like maybe you want to write it 100 times, that is 2 raised power of 100. Okay, instead of it to be writing 2 times 2 times 2 times 2 in 100 times, just come and bring the idea up as 2 raised power of 100. So this comes the idea of indices to mathematics to make it easy for us to represent a certain number with instead of it to be writing a large number 2 times than this. So these indices will help you. Okay, this indices, it has what law we have. Okay, let's dive into the law of indices. Yeah, okay, we have the first law I have on my list here is multiplication law. You are familiar with this very well, right? So some of you may still have difficult to study this multiplication law of indices. So this multiplication law of indices states that when you have a expression like this in mathematics, we have a base power of let's say is n multiplied by, we have a base power of of n. So whenever I see an expression like this, just remember that it is multiplication law of indices. And this one, according to multiplication law of indices, now to express this one in this index form, since this base here, the first time here the base is a, and second time here the base is is a. Since they have the same base, take one base out of it, that is a. So take the first index, write it as n, and this multiplication will change to plus, and take the second base, that is second index rather, that is plus n. So whenever I say expression like this, it will give in this form. So whenever I say expression like this, it is given in this form. So the multiplication here will change to plus at the index of it, since we have the same base. But if in case you don't have the same base, so you don't have any solution then. So let's go to the division law of indices. So the division law of indices say that whenever you see a question like this, we have our a raised power of n divided by, we have a raised power of what? Of m, or it can also be written like, it can be written as this one. If we have our a raised power of n divided by, we have a raised power of m. So it's still the same thing. Okay, either you have it like this or you have it like this. It's the same division of indices. So whenever I say expression like this, and whenever I say expression like this, so what we just have to do now is to express it now. Since they have the same base, you take one base out of it. So we have what? We have a raised power of what? Of n. The first index is n. Why this division will change to minus? So we have our minus what? We have minus m. Okay, so that is second index. So the error that students used to do it here, students sometimes when they have it like this, they can say that this one divided by this isn't the same. They say this is not divided by this. No, it does not work like that. No, don't make that mistake and don't make that error. So when you say expression like this, you express it in what? In these parts. This is the answer to this particular expression. And whenever you say expression like this is the answer to this one, or this is the answer to this expression like this in mathematics. That is law of indices, and that is law of division law of indices. So let's dive into the the third one, that is power law of indices. Power law of indices states that when you have expression like this, that is this one is 1. Let's say this one as 1 as multiplication law. This one is 2 as a division law. Let me say write the 3 here. That is the power law of indices. So whenever I say expression, we have our a raised power of n, and also the open bracket, and it's also raised power of what? Of m. So this a is raised power of first power. The index is n here, and also it's still raised power of m. So this law, something like this, is called power law of what? Indices. So whenever I say expression like this, you call it what? Power law of indices. Okay. So how do we solve when you have a power law of indices in any given question? This one can be expressed. The solution to this law is given as this. If you open this bracket, the index here multiplied by the outer index. So this will give us a raised power of n multiplied by n. Or you can write it like this as a raised power of n and m. Or you can interpret it like this as a raised power of m multiplied by n. Either you write the solution like this, or the solution like this, or the solution like this. It's still the same thing. Okay, whenever I say expression like this, know that it is written as this, and whenever I say expression like this, know that it is written like this, and whenever I say expression like this, know that it is written as what? As this. Okay, let's go to the next one. That is a zero law of index. Zero index one law of indices. So let me put that question, the number 4 here. So to solve this question now, zero law of indices. So whenever I say expression that is have a raised power of 0, okay, know that anything raised power of 0 according to law of indices is equal to what? 1. Either it's a zero index law, or you call it what? Unity index. So it means that anything raised power of 0 is equal to 1. That is not what there's a proving for that, but for the sake of this video, I'm not giving the proving. But if you need the proving, you can let me know in the comment section. You can let me know in the comment section. And in case you are just new to my class, I'll drop the link where you can join our WhatsApp channel, WhatsApp group, and also our Telegram channel in the description below or in the comment section, guys. So, and in case you need the material I'm using to take my class, you need the PDF. Also, you can join our Telegram channel, also our WhatsApp channel, so you can download the material from there. Okay, so let's go to the next one. That is 5. So this one says that's negative index. So when it's in negative index, it's expressed like this. We have our, if we have an expression like this, we have a raised power of minus n. This negative index is in two forms. The first case to be this a raised power of minus n. This one can interpret the answer to this question. This minus as this index is the same thing as 1 over, okay? Minus is represented as this 1 over, and this a is raised power of what? Of this n. They have our a raised power of n. So whenever I say expression like this in mathematics, you can interpret this to what? To this. And whenever I say expression like this in mathematics, you can interpret it to this. This is the solution to this question, and this is the solution to this question. So in the another case, of this negative index. So if we have a fraction as a base, we have our a divided by b, and also raised power of what? Minus what? N. So this one, it says that to cancel our negative here, this is turned to the inverse of this base, where this b will goes up and this what? A becomes down, and this one will give answer to this question will be given as our b divided by a, and also raised power of what? Of n. Okay, and it's also be given as we have b raised power of n and what? A raised power of what? Of n. Either I give the solution to this or give the solution to this. So this negative index is in two cases. The first case is when we don't have it in fraction. This minus here is sent as 1 over. So don't make the error. When you have it this case, this is the best way to solve it. Okay, this is the best way to solve it. Interpret this one, change the inverse, make this base to be inverse. So it will be b over a and to raise power of n, and you can also open it like this. So don't make the mistake, and don't, because students used to make error with this particular question here. So whenever I say a question like this in indices, this is how you express it. Okay, so let's go to the next one, that is the fractional index. So we have number 6, fractional index. This fractional index says that whenever you have expression, okay, we have expression like that is our a raised power of that is 2 over 3. Okay, it's raised power of 2 over 3. So this one can interpret the answer question. Whenever I say expression like this, mathematics, the best way you can solve it, and the expression, the solution to this question like this is equal to this a, it will be the cube root of this, y is raised power of 2. So this can be expressed as we have the square, the cube roots. This 3 to be the outside there, it's written as cube root, and we have our a here, a raised power of 4. This a is raised power of 2. Okay, so if we don't want to do it like this, so you got to make it easy, you can express that we have our a raised power of 2 multiplied by 1 over 3. So this a is raised power of 2. Okay, and this one is the cube roots. Okay, we will discuss on that on this seventh law. So whenever you just know that when you have something like this, explain like this, that fractional index, that's a raised power of a fraction. Okay, this 2 it will be raised power of this 3. Why this will be cube root of what? Of this. Sometimes it will be 5 that is there, so this one will be represented as 5. So when you treat my example on this, you'll be able to understand it more and more again. Okay, so this is just the summing of these indices. So let's go to the next one, that is 7th. So I read the 7th law to on the 7th word to explain the way I explain it out like this. So let's quickly go dive into it. We have the 7th. Okay, the 7th is that the root power index law. So whenever I say expression like this, we have a raised power of 1 over 2. Okay, this 1 over 2, it means that the square roots, that you have to take the square root of what? Of a. This unity, it means that we have to take the square root of a. This one's supposed to write 2 here, because this one is already a square root before. So whenever I say half as a power, it means I will take the square root of this particular base here. So let's go to the cube roots. So when you have the cube root like this, when we have our a raised power of what? 1 over 3. So this one, the answer to this question is to be equal to, that will be what? This it will be cube root of a. It will be cube root of this a. Okay, because of 1 over this is the unity that gives us a cube root of a. And if we want to find the fourth root, we have our a raised power 1 over 4. So the answer to this, let me bring this one there. So the answer to this is be given as that is fourth root of a. So whenever I say the unity, you have a expression like this, you have a expression like this, you have a expression like this. This is how you express it. So whenever I have an expression like this is answer. Whenever I have an expression like this answer. Whenever I have an expression like this answer. So guys, that is a thing about what? Law of indices. That is everything about what? Law of indices. So guys, if you need the materials I'm using to take you right away, so we drop the link where you can get the material in the comment section. So you can join our group so you can download this material, guys. So let's stop the class today. So the next video you'll be looking at different example on this law of indices, that you can master this law of indices in 1 minute. I will look for the example for past question, for NECO past question and WAEC past question, JAMB past question, POST-UTME past question. and GCE past question and NABTEB past question. So in the next video, we'll be looking at solution, past question and answer under this law of indices. So guys, don't miss any part of that class. So this is the beginning of this class, and this is we start with indices. I have almost like 100 questions under these indices, and want to try to make the solution to that 100 question. So with that 100 question, if you can take your time and read that 100 question, if you need the material for that 100 question, the question and the solution, you can let me know. Join the link I will drop in the description below, or link I will drop, you can share in the comment section. Also you can join my Telegram group and Telegram channel there, and also my WhatsApp channel, so you can download the PDF of this particular class. So guys, thank you for watching there at this moment. So I would like you to share it across this social media, so people are looking for this opportunity, so they can get it, guys. Thank you guys, and God bless you as you do so. So let's go to the next class.